Today we discuss about antihistamines. What are these antihistamines? These are the drugs which are used to treat the allergic reactions and increase in acid secretions. Why we use for particularly allergic reactions as well as the particular increase in acid secretion means histamine, when it binds to the H1 receptor, it produces allergic reactions in our body. So that's why we are using antihistamines to treat allergic reaction. In other sense, histamine, when it binds with the H2 receptors, it increases the acid secretion. That's why we are using to treat the ulcer. Ulcer is nothing but increase in the acid secretion. So no, antihistamines generally they block the actions of histamine on its receptors, either H1 receptor or H2 receptors. So that's why what we are going to give exact definition of antihistamine means these are the drugs which are used to block the action of histamine on its receptors. If it is H1 receptor blocking action, then we call it as H1 receptor antagonist. What we call it as H1 receptor antagonist. If the blocking of action takes place histamine on H2 receptor, then we call it as H2 receptor antagonist. So we can classify antihistamine broadly into two classes. One is H1 receptor antagonist, H2 receptor antagonist. So today in this lecture we are going to study only about H1 receptor antagonist. These are the agents which are used to block the action of histamine on its receptor. Which receptor? H1 receptor. That's why they are called as H1 receptor antagonist. Why we have to block the action of histamine on H1 receptor means H1 receptor, when histamine binds with H1 receptor, it produces allergic reaction. To treat the allergic reaction, we have to block the action of histamine on H1 receptor. Now let us classify what are the agents which are associated with H1 receptor antagonist. Now we discuss with the H1 receptor antagonist. H1 receptor antagonist, what are the agents? There are two broad categories comes under that. First category is first generation. Second category is second generation. So in the first generation H1 receptor antagonist or antihistamine drugs, there are totally 6 particular class of drugs are there. In that first class of drug is amino alkyl ethers. Means there is an ether linkage here, ether linkage, and there is an amino group is there, and there is an alkyl group is there. That's why they will come under a category of amino alkyl ethers. In this we are having diphenhydramine. Diphenhydramine means by the name itself indicates diphen. Diphen means 2-phenyl group. On this particular carbon there is a 2-phenyl group, and this nitrogen is separated by ethylene groups, 2 carbon groups. So what happens, what is the structure means diphenhydramine. Diphenhydramine means there is a 2-phenyl groups are there and ether linkage is there, ethylene is there, and NN dimethyl amines are there. So it is called as a diphenhydramine. Now bromodiphenhydramine means the differences between diphenhydramine and bromodiphenhydramine is a example for amino alkyl ethers. Only bromine group on this particular phenyl ring. There is no bromine group here, you see, but here there is a bromine group. Rest of all structure remains the same. So the first class of drug is an amino alkyl ethers. Now the second class of drugs are ethylene diamines. Ethylene diamines. Now in the ethylene diamines, ethylene means CH2CH2. This is ethylene. Diamines means 1 amine group, 2 amine group. First you have to draw ethylene structure. On either side 2 amine groups you have to draw. So that is a way of remembering the structure. Ethylene diamine. Ethylene. This is called as ethylene. This is one amino group. This is two amino group. Both are diamines. What they are? They are called as diamines. Now what happens in this nitrogen atom? There is a 6-membered ring containing nitrogen. It is called as pyridine. What it is? Pyridine. 6-membered ring containing nitrogen. Pyridine. This is benzyl. So benzyl and pyridine is attached on one amino group. Two methyl groups are attached on other amino group. Example is tripylinamine. This is a structure of tripylinamine. Tripylinamine. Pyrilamine. Next structure is pyrilamine. So pyrilamine is another structure. The differences between tripylinamine and pyrilamine. Here also it is contains ethylene group, two amine groups, and a alkyl group one side benzyl with pyridine. But here there is a presence of methoxy group is there. Electron donating group is there. So electron donating group is present and it becomes pyrilamine. This becomes tripylinamine. Two examples of ethylene diamine is tripylinamine, pyrilamine. Third class is Pyrozines. What are these pyrozines? Means pyrozines, by the name itself indicates pyrazine means 6-membered ring containing nitrogen at first and fourth position. This is first position. This is fourth position. So first and fourth position saturated, they are called as pyrazine. So you have to draw the basic nucleus as pyrazine. So once you draw the pyrazine, then you can draw with the carbon having two phenyl groups and methyl groups. That is called as cyclizine. Example is cyclizine. On other side, meclizine. Structure is almost all same with a slight variation. Here you are having meclizine means there is a one hydrogen is replaced with the toluene group. Here only just methyl group is there, but here it is toluene group. Toluene group is there. So toluene group. And meclizine containing toluene. Mecla means methyl group. To the benzene, it contains methyl group. Toluene group substitution is there here. On other side, chlorine to the phenyl group. These are two structural features varied from the cyclizine. So they are called as cyclizine and meclizine. So finally, the fourth one in this generation is the propylamines. Propylamines means propyl means it is 3 carbon. 1, 2, 3. 3 carbons. Propylamines. So this is propyl, this is amines. So propylamines. Very simple. You have to draw the basic structure propylamines. And almost all methyl group on one amino group. On this particular propyl end carbon, terminal carbon, one is phenyl, one is pyridine. One is phenyl, one is pyridine. So this structure is very simple, phenyramine. What is this structure? Phenyramine. On other side is chlorphenyramine. The differences between phenyramine, chlorphenyramine is a chlorine. Okay, so phenyramine does not contain chlorine, but here it contains chlorine. So this is in a fourth class. So we will go for the fifth and sixth class of first generation. Fifth class of drug is phenothiazine in first generation. Phenothiazine means already we know that dibenzothiazine. Thiazine means what? Dibenzo means two benzene group. Dibenzo. Di means two. Benzo means two benzene or phenyl ring. Okay. So thiazine means 6-membered ring containing sulfur and nitrogen. Sulfur and nitrogen. We call it as a dibenzothiazine, which is commonly named as phenothiazine. There is a side chain similar as that of previous one. Amine is separated by the side chain with alkyl groups. Okay. So the example for phenothiazine is promethazine. It is called as promethazine. Promethazine is one example. The other example is trimipyrazine. Trimipyrazine. Promethazine and trimipyrazine, the only difference is one more extra methylene group is attached. One more carbon is extra here. Rest of all same. Trimipyrazine. Okay. So this is in fifth class in case of first generation. Sixth compound is dibenzocycloheptadines. By the name itself indicates dibenzo means two benzene groups, two benzene rings. Cycloheptanes means 7-membered ring, or the center 7-membered ring containing double bond. They are called as heptanes. So to one of the carbon there is a double bond and attached with 6-membered ring containing nitrogen. They are called as piperidine. This is called as piperidine. Okay, piperidine. So cycloheptadine example is cycloheptadine, dibenzocycloheptadines. In this you get a class cycloheptadine. The second example is azertidine. The differences between azertidine and cycloheptadine is here both are benzene, but here you get one is pyridine. But still it comes under a class of dibenzocycloheptadines. Exception case, that's it. Okay, so here one of the benzene ring is replaced with pyridine. Biosteric replacement. Carbon with CH is replaced by N. CH valence electron is 3, nitrogen valence electron is 3. Rest of structure remains the same. So these all are the classes of first generation. Now second generations, which are very effective drugs, are two examples: Flexophinidine, Cyclizine. Even levocitrizine also comes under this. Okay, Flexophinidine contains what ring means? Piperidine, 6-membered ring containing nitrogen, piperidine. And there is a side chain, phenyl rings. As usual, the structure is. Okay, so very huge structure is there, and it is an Flexophinidine. Carboxylic group is there. Here main you can see that piperidine ring is there. What is this? Piperidine, 6-membered ring containing nitrogen, saturated. On other side, if you see that, you can find here piperazine ring. Under citrizine you are having second generation citrizine, you are having piperazine. Piperazine means 6-membered ring containing 2 nitrogen at first and fourth position. So piperazine is a basic nucleus present in the citrizine. Many times they will ask what are the basic nucleus present in the citrizine in GPAT questions, and or GATE previously they used to ask, any competitive exams they used to ask what is a basic nucleus. What basic nucleus is present? Piperazine is present. Okay, so here carboxylic acid group as usual and diphenyl groups. So these are the second generation. This is overall H1 receptor antagonist.